Alright, so we have an example problem here on circuit analysis, three-phase. So the problem here is you're given a balanced three-phase with a voltage line to line at the source. The load is delta connected. You have a line impedance. They give you also the line current on one phase. And the question is to find the line-to-line voltage at the load. So first thing first, you have to draw the circuit, unless it's given, of course, but you have to put your parameters on the circuit to be able to visualize what you're doing. So you can either start at the source or you can start at the load, but let's start at the load. So it's a balance, it's a delta connected, right? So we have a delta connected load. They didn't give us load impedance, so we're just gonna assume it's nothing. It's not given. We are told it's ABC phase, so counterclockwise, positive sequence. And normally what I do with these problems, I highlight in my head, or you can highlight it and the problem, your keywords. And we've kind of said that already, three-phase as a keyword, ABC phase as a keyword. The line-to-line voltage is given, not the phase voltage. The delta load is a delta, not a Y connected. It makes a difference between the line-to-line voltages and your current, etc. Line impedance is given. Line current is given, not phase current. And the line-to-line voltage. So those are your keywords. You can put that kind of in your head to know how to solve the problem eventually. So kind of visualize that in your head. Right, it's a balanced three-phase. So let's draw the circuit. Excuse my drawing, it's kind of shaky a little bit. So we have been given a line impedance. So let's call that RA. And we are also given a line current on phase alpha. So let's call that IA. And the source voltage is line-to-line voltage. So that's for the entire system. So let's just put a source voltage here and connect all of them together. It's not, we're not told if it's whatever, like. So that would be your phase, your line, right? So this is your 12 kV. Okay, so we have RA is 2 plus J 4 ohms. IA is your line current, 50 plus J 100. So we have to solve the problem using a single phase, right? Per phase. So in order to do that, so this is what the question is asking you. So you can kind of see. So the question is asking you for VAB. Now on a balanced delta, in a delta configuration, your line voltages, your line-to-line voltages are equal to your phase voltages, right? In a delta configuration, line voltages are equal to your phase voltages. So in order to do this, we have to be able to get the phase voltages and solve this per phase first, and then bring it back to line. And there's some confusion also between line and phase. Where do you put the square root of 3? So remember this. Line is always bigger than phase, because your line is your entire system, but your phase is only one phase, right? because we're talking three-phase here. So your line voltage is your line current is for the entire system. Line is for your entire system. Phase is just per phase. So you know that line is always bigger than phase. And so if you're given line, to get to phase, you got to divide. If you're given phase, to get to line, you multiply, because line is bigger than phase. So that's how I remember it. So from here, let me use a different color. So let's use green. All right, so here is just a simple phase circuit, right? I mean, it's just a simple circuit analysis. You have a voltage. Here also you have a voltage because V equals IR, right? Let's put here. And you were asked another voltage over here. So if we solve this per phase, we have 12 kV per phase. So that's square root of 3. So we're only looking at this section right here, alpha phase, right? If you follow my the pen. So you have a source voltage and you have a voltage. So there's a voltage drop over here. In order to get this, you subtract this voltage over here, the voltage IARA. So that'll be minus 2 plus J4 50 plus J, right? So because this is V equals IR, this is your R, and this is your current. So you have your voltage minus this voltage over here, because it's a voltage drop across the resistor, and you will get your phase voltage across A. So calculating this, I got 724 kV. Now again, this is your phase voltage, and in order to get your line to line voltage, you multiply by square root of 3, going back to line, right? So your final answer would be 724. Your VAB is equal to 724 times square root of 3, and that gave me 12.5 kV. So I think one thing to remember in this problem is just to draw it. Once you draw it, you'll be able to visualize it, and to be really careful between line to line and phase. Solve the problem per phase, and if you're asked line to line, bring it back to line, to the line voltage for the entire system. So our answer is 12.5. Let me know if you have any questions.